In this video, we will simulate a series parallel circuit using LTspice and also perform the experiment on an actual breadboard in the lab. So first what we're going to do is simulate this circuit. We're going to record all the voltages, and then we'll do the same thing on the breadboard and compare our results. So here's our circuit. We've got a DC power supply of 16 volts, and we've got an R1, an R2, R3, R4, 5, 6, 7, 8, 9. We have 9 resistors with different values, and we're going to measure the voltage across all of these resistors, and then we'll perform the same experiment on an actual breadboard. Alright, so let's begin the simulation. I've got a transient simulation for 1 millisecond. And the way you set that up is go to Simulate, Edit Simulation command, choose Transient, and stop time for 1 millisecond, and hit OK. And then we want to run the simulation. Alright, so you can see here, now we've got a waveform viewer. And if you look on the horizontal axis, this is time, and it's going up to 1 millisecond, which is what we specified. And here is the actual circuit itself. And it's really very easy to do. So what we're going to do is we're going to place our cursor on the left side of R1 and click and drag to the right side of R1, and you see the probe will fill in black there, just like it filled in red on the other side of the resistor, and release. And we can see that this is 3.30 volts. And if you want to get an even more precise reading, you can actually add if you right click and add a cursor. So let's attach a cursor. That brings up this window here, and you can get even a more accurate reading. So this is 3.309, so I'll round that up to 3.31. Alright, so we're going to put 3.31. volts. So 3.31 volts for the first resistor. So I'll close this out and left click inside this window to make sure it's selected, and click on the cut button and click on here to delete. Alright, so we'll come down to our window that has the actual circuit and select this window by left clicking, and we're going to do the same thing. So let's measure, left click on R2, drag, and release, and this looks like 12.69. So this time I'm not going to add the cursor because I can read this pretty accurately as 12.69. Go back here, make sure I've selected the waveform window, and I've got the scissors icon, so I'm going to left click and delete that. Left click down here to select the circuit window. Do the same thing for R3. This is also 12.69. select this window, delete, select this window, measure our VR4. This is 4.60. So again, I don't really need to attach that cursor. I can get this to hundredths precision. So 4.60 volts. And delete that. Okay. Now R5, R6, R7, they're all in parallel, so they're going to have the same voltage, but I'll do them individually anyway. Now this is 421, about 422 millivolts. So that'll be 0.42 volts. And same thing for R6. 422 millivolts. R7. 422 millivolts. Measure the voltage across R8. This looks like 7.437. So we'll round that to 7.44. And finally, we'll measure the voltage across R9. And this is right at 228 millivolts. So we can round that to 230 millivolts. So 0.23 volts. Okay, so those are our results for LTspice. So you can see that's pretty straightforward. We're just clicking and dragging across each resistor. So left click on one side, hold down your mouse button, drag to the right side, and release. Alright, so now what we want to do is compare this to what's on the actual breadboard in the lab. Now we're going to make the measurements on the breadboard, and we'll compare these measurements to what we got from the LTspice simulation. So first off, notice that we have the DC power supply, and it is set to 16 volts. We're bringing in the power to the breadboard here, into these posts. Then from these posts, we bring the power into the rails here, and then we connect from the rails to our actual series parallel circuit. So let's go ahead and measure those 9 voltages. VR1 is going to be across resistor 1. So I'll go ahead and measure that. And we'll observe what we get on the multimeter. So we're going to make sure the multimeter is set to DC volts. Okay, and that we have our probes plugged into these two places here. Okay, so let's measure VR1. 3.32 volts. So that's 3.32 volts for VR1. VR2, 12.76 volts. VR3, 12.76 volts. VR4, 4.63 volts. VR5, 0.42 volts. VR6, 0.42 volts. VR7, 0.42 volts. VR8, 7.47 volts. And finally, VR9, 0.23 volts. Okay, so now let's compare what we got with LTspice. Okay, so these were the values we just measured on the breadboard. So we got 3.32 volts on the breadboard, 3.31 volts in LTspice, 12.76 volts on the breadboard, 12.69 volts on LTspice, 4.63 volts for VR4, 4.60 volts for VR4, 0.42 volts versus 0.42 volts for VR5, 6, and 7, 7.48 volts versus 7.44 volts, and VR9, 0.23 volts versus 0.23 volts. So as you can see, our results match up very, very closely between what we got on the actual hardware versus what we got in the software simulation. Okay, so that will conclude this video, and I hope that it's been helpful.